let's try this one more time. Section 4.2, we're going to discuss linear and non-linear inequalities in two variables. Well, by an inequality, let's see if I can get some white paper here. Clean scratch papers. See, if you have equality, see, A equal to B. This is an equation. Okay, something equal to something else. If you don't have equality, we have A less than B, or less than or equal to B, bigger than or equal. Either one of these. Instead of equality, any of these four, then it would be inequality. Okay, so that's what we're trying to discuss here. So basically what we're going to do, we're going to look at, we have seen equalities, we call them equations. Now we have inequality. X, A and B involve both X and Y. Okay, so these are the simplest inequalities that we can have. Basically polynomial inequalities. The very basic ones, that would be linear inequalities. That's what we're going to discuss here. Okay, so okay, so let's see. So what are the basic linear inequalities, and a few maybe non-linear inequalities. So, but by a linear one, we mean something like this. You see, some number A times X plus some number B times Y, both to power 1, less than C, or maybe one of the other three, less than, equal, bigger than, or bigger than equal. If you have one of these four symbols and a number on the other side, we call it a linear inequality. Basically, if you graph, here's my paper. If I have AX plus BY equal to C, then we can graph this. You see, if we graph this, this is a straight line. Actually has a slope and y-intercept. We can make it look like that, but we won't. Basically, if you graph this line, you get a straight line. Okay, it's a line. So for that reason, we call this one linear equation. Okay, but when we have linear inequality, okay, then that means to the either side of the line. Okay, that's the solution. So in this case, equal to C, the solutions are points exactly on the line. But when you replace that equality by an inequality, then you are looking at points off the line. So it could be points to one side of the line compared to the other side. Okay, and we basically can find the solution by, if we can get this line, then we can actually check which side would be the solution. We can show that to you later. But first, let's look at some examples of linear inequalities. See, these are already marked, so I don't have a new copy. 3x plus y less than or equal to 1. This is linear. This is linear. This is non-linear because of this power 2 makes it non-linear. In this case, actually we can call this parabolic. Okay, because x is squared but y is not. This is circular actually. So this is non-linear. This is linear. This is a special case when coefficient of y is 0 here. and this is situation. This is the situation where coefficient of x is 0. Okay. Now the next thing we're gonna learn, as again, my copies already wrote on that. Already did this video, but didn't have audio, so I'm doing it again. That's the problem. So the question is, what do you mean by a solution? By a solution to an inequality, you mean a point that satisfies the direction of the inequality. For example, if we take one of these examples here, like 1b, that's what the one we're going to look at. 2x plus 4y bigger than negative 8, and then replace x by 1 and y by negative 3 in this equation right here. If we get left side bigger than negative 8, then we say a solution. If it's not, then it's not a solution. Let's see what happens. Replace x by 1 and y by negative 3. We did right here. You see 1, this is negative 3. And if you work this out, you get negative 10 on the left side and negative 8 on the right side. And this is not. No, it's not. Negative 10 is not bigger than. So 1 and negative 3 is not a solution as it was said, as the question was. Okay, so it's not a solution. But if you try negative 3 and 1, replacing x by negative 3 and y by 1, then you get, after you simplify, you get negative 2 bigger than negative 8, and this is a yes. It is true that negative 2 is bigger than negative 8. That means negative 3, 1 is a solution. Okay, and if you plot these points, you see this one right here in green is a point in xy plane which is not a solution, but this point is. So the question is, how do we know which points are solution and which point aren't? The answer is very simple. In simple case here, for example, usually all the solutions and non-solutions are separated by a line. That line is the border line between one side and opposed to the other side. Actually, what happens, we always have a line whose equation is given to us in terms of x, y, and in most cases this is just a straight line, because we're going to deal with nothing but linear inequalities. Okay, like this situation, you see, if we have if I have ax plus by equal to c, then if you graph this, you get this straight line. Okay, but if it is not equal to c, if it's bigger than c or less than c, like situations that we have here, you see, we have this kind, then it wouldn't be on the line anymore. It would be either to one side of the line or to the other side of the line. So this way, solutions are separated by a straight line if it's linear. If it's not linear, we may have certain other forms, like if it's parabolic, then you have a parabola here, like this is, let's say, like that, and then I have points inside of the parabola. Remember, this goes forever, opposed to points outside of the parabola. See? So in this case, we have non-linear inequalities. This way we can check whether points inside the parabola are the solutions or points outside. And also in that process you can tell whether the border line itself is included and that is determined by whether we have equality with the inequality. If we have equality, like this case, less than or equal or bigger than or equal, then the line itself would be included into the solution, and then we draw it as a solid line. Otherwise, we draw it as a dotted line indicating that points on the line are not the solutions. Okay? That's what we have. So let's look at the basic situation. So in general, then we have a straight line or some other line. Then we have one side of the line and opposed to the other side of the line. Okay, so one side of the curve and opposed to the other side of the curve. So basically the solution to the inequality we have would be one side of the line or the curve. Okay, so to find it, basically what we do first, we get the graph of this line, which is going to be a straight line in most of the cases, and in some other other cases, a few other ones, maybe this is just a parabola. Nothing really complicated here. So basically what we do, we first draw the graph of this line or this curve, and then by choosing a test point on either side of the line, any point off the line. For example, if this line doesn't go through the origin, then the origin is the best testing point, because you have 0, 0, you can check. Okay. But if it goes through the origin, then you have to check, use other points other than the ones on the line that includes the origin. So this way you can determine which side is the solution and then shade it. And I'll show you both with and without a calculator how you can do that. Okay. So, like here we have this inequality right here, 2x negative 2x plus y less than or equal to 2. So the first thing you do, you just think of this as equality to get the line. Okay, so I graph it, because to graph this, basically if it's linear, you see this is linear, I draw a cross here. Okay, and I put x here and y here. Then I choose some easy values for x, just 2 values, because I know the line is a straight line. All you need are 2 points. You can plot those 2 points and then connect them to get the whole line. Okay, so the easiest point for a value for x I can try is 0, of course. So if I choose 0, have 2 0 plus y, then I get y equal to 2. If you think of it as just equality, you see negative 2x plus y equal to 2. I'm looking at this, the line itself. Then then another value you can choose is choose y to be 0. These are the intercepts, the easiest points to find. So if I put y equal to 0, then I can compute x to be negative 1. Okay. Then you plot both of these 2 points, 0, 2. Let me see if you can see it. Yeah. 0 and 2 is right here. 0, 2. And then negative 1, 0 is right here. The line is, I know it's a straight line, so all you have to do is to draw a line through those 2 points. Okay. And I drew it solid because in the original inequality you have equality, so the points on the line are part of the solution. Then you need a test point. Okay, so you say test point. Test point. Of course, you see this doesn't go through the origin. The easiest test point is 0, 0. So if I put 0, I'm checking the right hand side, because that's where this point belongs to. 0.00. So put x and y equal to 0, both of them, negative 2 times 0 plus 0. Then the question is this question mark less than 2? The answer is yes, because 0 is less than or equal to 2, yes. So that means there's this side of the line, every point on this side of the line where this point 0, 0 what belong to the solution. So I shade it like this. Okay, that's how you do it. Okay, now I'm going to show you how to do this with your graphing calculator. So we get my calculator here in just a second. Okay. The first thing you do, you just write it right here, you see. Negative 2x plus y less than or equal to 2. Okay, so I want to do this. So what I do is to solve this inequality by solving for y in terms of x. That means y by itself on one side, maybe on the left, and everything else on the right. Okay, so to do that, I add 2x to both sides. Then these two cancel out, you get y. These two cancel out, you get y less than or equal to 2x plus 2. Okay. Now that I have it in this form, I put this in my calculator and I show you how to get less than or equal. So, this one bigger. Y equal to right here. Okay. I have 2x plus 2. Here we go. 2x plus 2. Okay. Right here. Y less than or equal to 2x plus 2. And then with this cursor right here, with this cursor, by this, just back up like this and has to continue going over the equality, backing up like that, and then one more. Now you see that thing at the very left end start blinking, changing shape. If you keep pushing enter, you see it's changing shape. And at some point it's like a triangle, the 90-degree triangle to the right, and it becomes let's see it. Let's see. Do it again. Push enter. There we go. There we go. This is the inequality to the top. It's the upper half triangle. If I continue again, now is a lower inequality. You see, so the one on the left, lower one, that means less than or equal to, and then the one on the right, this one means bigger than or equal to. Okay, so now if you look at what we have less than or equal to. Okay, so I'm going to go ahead and choose. Over again. There we go. This is less than or equal. Say enter. No, I'm sorry. I should have said graph. Okay. Okay. Then graph. Let's look at your window. Let's see what the window is. That's fine. So say graph. You see, shades the same side as what I have graphed right here on the paper. It's exactly like. So that's how you do it. You have to write it as y, and then with that enter situation, choose the correct inequality and say just graph. Okay. So let's look at maybe another example. Next example is this situation of a non-linear. Okay. Non-linear because we have x squared minus y less than or equal to 4. So if I write this one as x squared minus y equal to 4, then you get y equal to x squared minus 4. See, so what we have here, then we have a parabola. You see, this is a parabola that is being moved down 4 units. So if this is minus 4, it's like this. This is y equal to x squared minus 4. This is the borderline. For this inequality, this is the borderline. So you have points inside versus point outside. And you want to know which side are the solutions. The line itself are all solutions because we have equality. Then you choose the easiest point, which is 0, 0. This point. Put it into the equation x squared minus y less than or equal to 4. So 0 squared minus 0 less than or equal to 4. The answer is yes. Okay, so that means the inside points are the solution because 0, 0 is one point that works, and every point else on that side also will work. So every point inside has the solution. Okay. And the other one, this other problem is similar to this. So, but, in this case, we have a straight line. Okay, we have improve quality of life here. 3x minus 2y bigger than 6. This is linear. So what we do, basically, easiest way to do it is to. By the way, if you want to do this one by your graphing calculator, this x squared minus y less than 4, then if you solve this one, this becomes a y bigger than, actually, see. Then you can put this in your calculator to see if whether points inside or outside would be shaped. So let me just work it out up here. I won't mess up. But let's not mess with this equality. So here, put this one take y to the right side and 4 to the left side. So x squared minus 4 less than or equal to y. So that means y bigger than or equal to x squared minus 4. Okay. So what I did, I just solved the inequality. Then I go to my calculator. It's x squared minus 4. See, bigger than. So I say x power 2 minus 4. Say graph. There we go. These are the graph. Now I have to go back and put the correct sign. So go back here. So go back. And now enter, because I have y bigger than or equal to. So there we go. I choose this triangle. It means bigger than or equal to. Bigger than. So I say graph. See, in the points inside the parabola are shaded, which is consistent with what I had here. Okay. Let's go back and continue with the next example. I just started it like this. Put x and y in this table and try some easy numbers for x, like 0. If I put x equal to 0, I'm looking at equality. Let's just put 3x minus 2y equal to 6 for a second and draw this line. Always put this to the equal and draw the line. So this is without a calculator. Okay. So if I put 0 for x, I get y equal to negative 3. Another easy point is when y is 0. If I put y equal to 0, then I have 3x equal to 6, I get 2. Okay. So these 2 points are easily plotted. 0, negative 3 is right here. Okay. And then 2 and 0, 2 and 0 are and because I know it's a straight line, and see I have don't have equality, it's non-equality, it's just inequality, no equality. So I'm going to draw this line dotted line. Okay. See, this is the line. This is the line. 3x minus 2y equal to 6. Now the only thing left to do is to determine whether points on the left or points on the right are the solutions. For that, you do the test value, test point. Always is 0, 0. If 0, 0 is not on the line, then that's the best point. If I put 0, 0 for x, I get 3 times 0 minus 2 times 0 bigger than 6. 0 bigger than 6. Question. The answer is no. That means this side where 0, 0 came from is not the solution, it's the opposite side. All the points on the left side of the point, and the line itself is not included. Okay. Finally, we have one, this is an easy one, because variable x is missing, so the borderline is horizontal. If I write this divide by 3 like this, you get y bigger than negative 4/3. 4/3, this is 1 and 1/3. 1 and 1/3. This is 1. This is 1/3. It's right, somewhere right here. This is negative, so it's gonna be underneath. About negative 1.3. So this point, negative 4. So at this point we draw a dotted line because we don't have equality. So it goes like then, of course, points above are the points which are bigger than that, so the solution is on the top. Okay. Because we have y bigger than that, that is above. It's very simple. So that's the only thing here is right line. Okay. Generalizing this thing here. Okay, so let's see. Okay. Generalizing this idea is not really too difficult. Basically what we have is this. Now what if we have more than one inequality? Okay, so here's my extra paper. Let's say I have two inequalities. Okay. A1x plus b1 y less than or equal to c1, and some a2x plus some b2y maybe bigger than or equal to c2, something like that. Both linear. You see, if you understand the linear part, then you can easily extend your imagination to non-linear situation very easily. Basically two curves. So what we do is to solve each one separately. So you solve, if I say this one L1, this one L2, then I graph L1, I get a line like that, let's say. And for this line, I happen to have this side the solution, let's say, for the sake of discussion. And then I go and do the same thing with second equation, and I get something like this, let's say. And then this is L2. Then for this one, maybe this side is the solution. Then the question is, which, so you have four parts here, four regions. You see one, this angular thing, then another one right up here, here, and here 4. So the question is, which one of these 4 sections are the solution points? The answer is that the region with both colors share both common solution. That means the region with both colors in our case. We have green here, and we also have red. So this angular thing down here is our solution. Okay, so that's the generalization of the situation. Let's just do a couple more. 4 examples to work problem here. Let's see. Let's do this quickly. I do one of them with the graphing calculator as well. So basically what you do is like following. First, I'm going to call this one line L1, call this one line L2. Okay. Then for L1, we have this situation. X and 1, Y. Put X equal to 0. I get Y equal to put X equal to 0, I get Y equal to 9 divided by 2. And if Y is equal to 0, I get X equal to 3. And if I go ahead and graph this, 9 over 2 is 4.5, 4 and a half. Okay. This is 4. This is 1, 2, 3, 4. Each one is 1. So 1, 2, 3, 4, 4 and a half is right here. And 0. So it's right between them. That's the first one. 0, 9 over 2. And then 3, 0, which is right here. So let's do it one more time. Plot this point is 0, 9 over 2, which is 4 and a half. It's right up here. 1, 2, 3, 4, 4 and a half. And then 3 and 0. 3 on x-axis and 0. So what you get, and then you have equality, so you get a straight line L1. And we just do this maybe a little bit decent. And it's solid because you have equality. And the second one, let me use a different color. L2. Put it here, L2. Let me do the test point here as well. The test point 0, 0. So 3 times 0 plus 2 times 0 is less than or equal to 9. Yes. So that means this side of the line is the solution. So line L2 is the same. X and Y. Put X equal to 0. Put X equal to 0, I get Y equal to negative 2. Put Y equal to 0, you get X equal to 5 over 2, which is 2 and a half. So 0, negative 2 is right here. See, this is 0, negative 2. And 5, half, and 0, 2 and a half. 3, 2 and a half is right there. It's going to be okay. Then test point. This point 0, 0, of course. You see 0, 0 is not on that line. So with the second equation, 5 times 0 minus 0 bigger than or equal to 2. No. So that means for the green one, this side is the solution. Maybe I should use red. I should have used red for the red one. This side of the green one is the solution. Okay. So, Yeah, I should have used red for L1 since I did it in red, and then green for green line. I did it opposite, but that's okay. This region right here wouldn't have changed if I changed the color around. So this triangular shape is the solution. Okay. Let's do one more here. This is a little bit different in the sense that all the activities occurs in the first quadrant. So if this is x-axis here and this is y-axis, then you really don't need the negative values for x and y, because these two conditions here say that all the activities occur in this quadrant right here. Don't go anywhere. Okay. But if you draw any line, you just draw the restriction in this. Like if you have a line really big, you just consider the piece that we have in this particular region. Okay. So let's see. Again, you just go ahead, do the same thing we did as before, but we apply this restriction here to see what happens to the region. So again, I want to call this one L1 and L2 for L1. Let's see for L1. Put x equal to 0. If I put x equal to 0, I get y equal to 15. Now if I put y equal to 0, these are the easiest point you can try. If they don't work, then you have to try other points other than intercepts. Y equals to 0, you get x equal to 20. Okay, then 0, 15 is right here, and 20, 0 is right there. So what we get is this line and solid. Then you have equality. Just that part in first quadrant. And test point (0, 0). I just say it because it's easy. If you put x equal to y 0, you get 3 times 0 plus 4 times 0 less than 60. The answer is no. Okay. The 3 times 0 is 0, 4 times 0 is 0, 0 less than 60. Yes. Sorry, the opposite. Yes, it's less than 60. Okay, so that means this side of the line is the solution. And for line L2, see this one, put x equal to 0. If I put x equal to 0, I get y equal to 10. And if I put y equal to 0, I get x equal to 30. So let's see, 0, 10, right there, and 30, 0 is right here. So the line we have in this case, find my pen I was using. If we connect those 2 points, like that, and then there's a test point. (0, 0) gives 0 plus 3 times 0 less than or equal to 30. The answer is yes. 0 less than 30. So this side of this line is the solution. So the solution to the whole thing is this trapezoidal shape, and go around it with the black here. this is this region. I'm going to call this one a name. Let's call it the feasible region. Feasible region. So the only thing we need to find are the corner points. So this point clearly is 0, 0. This point is 20, 0. Okay. And this point is 0, 10. So the only point is to find this point right here. Okay. Question. To do that, you take these two equations right here, L1 and L2, and write them with equality and solve it. So I'm going to go ahead and write that as, okay, I say intersection point. See, 3x plus 4y equal to 60. X plus 3y equal to 30. Okay. If I solve this, I get the intersection. And this is easy because all you have to do is to multiply this lower equation by a negative 3. If you do that, then you get 3x plus 4y equal to 60. Then negative 3x negative 9y equal to negative 9. See? Then this cancels this. Negative 9y plus 4y, you get negative 5y if you subtract, equal to negative 90 and 60 give you negative 30. So y is equal to 6. Okay. So the y value of that point, 6 right here. Put this 6 into one of the two equations, either one. Like if I put it in the second equation here, see, x is equal to negative 3y plus 30, negative 3 times 6. It's 30. So x, this is negative 18 plus 30, you get 12. 12 for this point is 12. Let me just quickly go over. Do you want to find the intersection point? You just take the inequalities you have. This inequality is just those two, and write it with equality like this. This way you are drawing, intersecting the line, the border points. Then if you solve for x and y, like I got here, x equal to 12 and y equal to 6, then that would be, those two numbers would be the coordinates of the intersection of the two lines, two border lines. We call this a feasible region. Maybe okay, if you want to do this this problem with the graphing calculator, this one, let me show you that really. So this is in graphing calculator, so I gotta get a piece of paper and do it right here. The first thing you do, you have to write these two inequalities, just those two, as y by itself on one side. So 3x plus 4y, that's the first one, L1. less than or equal to 60, then just subtract negative 3x. We just take 3x to the right side for y less than or equal to negative 3x plus 60. And if you divide by 4, y less than or equal to negative 3/4 y plus 15. Okay, you see, so I have y by itself. Now I can put it in the calculator. Similarly, let's do it for L2. For L2, I have x plus 3y less than or equal to 30. If you take x to the right side, 3y less than or equal to negative x plus 30, then divide by 3, y less than or equal to negative 1/3 x plus 10. Okay. These are the two equations that we can put in the calculator, and then if you choose correct inequality, then it would shade the region that you want. Of course, you just have to choose x bigger than 0 and y bigger than 0 situation, because that's what you have. So let's do that. Let's put this in the calculator. The first one is let me see. You have it and I have it, so I'm going to just put it in here. First one is parentheses negative 3 divided by 4 times x plus 15. Okay, and then you go back. I have less than or equal to, so I have, there we go, less than or equal to. Then I just move to the next line. The first one stays that way. Then we can do the second one. Second equation is negative 1/3 plus 10. Negative 1 divided by 3 times x. Oh, I didn't even do anything. There we go. Negative 1 divided by 3 times x plus 10. And then I think I'm going to just say go ahead and graph it for the standard thing. So I haven't chosen what inequality I want. I want less than and equal as well. So both of them, you see. So then say graph. Well, problem is that the window is not big enough, so let's say minus 20 to 20, so from minus 20 to 20. I don't know, what am I doing here? This is Windows. Do I have correct equations? Okay, now make this smaller a little bit. Okay, these are the two equations, and I put them in my calculator right here, you see. And then when I say graph, see, it graphs one line on one side of it, and graphs the other line and one side of the other one, and the The region with both shades is a little bit not easy to see. Let me, if I change the window, you can see it better. Maybe I should go from let's make this one to 40. This one to 40 as well. So let's. Anyway, this is gonna show better. See, the region that has both shades is the reason. Now if you want to find the intersection point, all you have to do is to go to calculus here. You see calculus, so you have to say second trace. You see second trace, so let's do that. Second trace. And then you see the item number 5. Item number 5 is intersection, so I choose that, number 5, there we go. Now that cursor is blinking on one of the lines, just say enter. And now it says second curve, blinking on the second one, push enter again. And now it says guess, if you enter again, the bottom of the page, it tells you the coordinate of the intersection point. And we worked hard on paper to do it without the graphic calculator, which is 12 and 6. Okay, so that's how you do it. Okay, let's see what else we have. Maybe there is another one here. Next one is similar. I'll let you do that, you know, the same, well, this one is actually much easier than that, because you have for this one, for the line L1, x, put x equal to 0, then y equal to 4, put y equal to 0, you get x equal to 3. So 0, 4 is right there. 3, 0 right here. So this is the line. And then it turns out that you want, let's see, test point 0, 0, 4 times 0, plus 3 times 0 less than or equal to 12, yes. So inside of this line, and then x between 0 and 2, between 0 and 2 means this is 0, this is 2. You draw a vertical line at 0, x equal to 0 and x equal to 2, like this. Solid because you have equality. This is x equal to 2 and this is x equal to 0. And then you want in between, so it's going to be like this, between 0 and 2, x value. This is strip right here. And y between 0 and 3, and 3 is right here, you see. And you want less than that, and between 0. And then you want a region, maybe you should find my green, if I can find it. Let's go on. The region between these two. So the region actually we want is highlighted with really thick between these two lines to the left side of this and between these two lines. That's the region. This is the feasible region here. Okay. And these points are easily found because this is x equal to -2 and y is equal to 0. This is x equal to 0, y equal to 0, and this one you have to find intersection points here. Then so this point is actually 0, 3, and then you have to find two intersection points by putting. So like if I put x equal to y equal to 3, put y equal to 3 here, you get 9. Yeah, I'm not gonna find those points here at this point. Really doesn't matter. So that's the situation. If I use a calculator, then I will, but I actually can, because you see I have this line. I have 4x plus 3y. This is equal to 12. Okay, is this line. And then I intersected with y equal to 3. I put y equal to 3, 4x plus 3 times 3 equal to 12. This is 9. So you get 4y equal to 3. So y equal to 3, 4. Okay. So this point actually, this point is x is equal to, I'm solving for x, not y. X is equal to -3, 4. See, like this one. Okay, I guess I didn't want to take too much time, spend too much time on something so simple here. So just basically you want to find the region, how the region looks like. You know, if you want to, you can find those points if it's easy. This one is actually a parabolic one. So let's just do this one with the graphing calculator, actually the whole thing. So I subtract 2x from both sides of this equation, get y equal to -2x plus 1, so less than or equal. Here is you have a negative y. I take it to the right side, so x squared, then take 2 to the left side, then less than or equal to y. If you flip this around, y bigger than or equal to x squared minus 2. Okay, so you have the two inequalities you want, and then you have to graph each one and choose one side of each one, get the solution. So if I call this one L1, this one L2, for L1 x and y, if I put x equal to 0 and then y equal to 1, if you put x equal to 1, it's an easier point, you get y equal to -1. Okay, so 0, 1 is right here. 0, 1, and 1, -1 is right there. So we have this line. For L2, see L2, I have y equal to x squared minus 2, and this is a parabola that moves down 2 units. So like that, the parabola like this, and then it's moved down 2 units because there's negative. We studied this, remember? I'm solid, and my parabola didn't come out very neat. This is L2, L1. Then test point for the first one, for L1, test point L1, 0, 0 is right here. You see, he's on neither one of the curves. 0 plus 2 times 0 less than 1. Yes, it is. So for the line is side to the left side. Okay. Now for this test point for L2. For L2 is also 0, 0 because it's not on the other one either. So you put the second one, 0 bigger than or equal to 0 minus 2, yes. So I wish I could find my screen. Okay, oh, I found it. So it's gonna be inside the parabola, see? Parabola gonna go up like that. And the region is that. Okay. It has both colors, you see. All of this is green, all of this is this, and then this area here. One is the solution. Okay. And that's all I'm gonna say here. This last problem, hopefully we see it in the context of next section. Okay. So thank you for watching.